we'll be tackling Haber process basically. First off, let us know what Haber process is about, also known as Haber-Bosch process. Responsible for synthesizing ammonia.
As we gear towards advancement of the industrial sector, different processes of manufacturing plays a big role keeping this sphere running. Hello, we are the Synthetic Corporation, and our manufacturing company is widely known for the production of ammonia, which came from the Haber process.
However, more discoveries were made as we continue the production of said substance, and we believe that despite the huge help that it gives us, we should not overlook its side effects. This is why we aim to campaign, discuss, and give you more knowledge about the Haber process, along with its benefits and adverse results.
You may ask, what exactly is the Haber process? The Haber process is an artificial nitrogen fixation process developed by Fritz Haber and Carl Bosch in 1910. In 1912, construction of a plant with a commercial production capacity began at Oppau, Germany. It is a method of directly synthesizing ammonia from hydrogen and nitrogen, which is what we produce in our company.
The process combines nitrogen from the air with hydrogen by natural gas methane into ammonia. The reaction is reversible and the production of ammonia is exothermic.
The Haber process is currently the main industrial procedure for the production of ammonia, given that it is used to make nitrogen-based fertilizers which can be used for agricultural purposes. The Haber process involves the conversion of nitrogen and hydrogen gas into ammonia using a metal catalyst.
First, gases are passed over 4 beds of catalyst at high temperatures and high pressures. Between each pass, the mixture is cooled and any unreacted gases are recycled. Each pass is only 15% efficient. However, recycling allows for a conversion rate of 97%.
The flowchart of the Haber process looks like this.
The Haber process is known to have 3 general conditions, first of which is the catalyst. The catalyst has potassium hydroxide added to it as a prompter, a substance that increases its efficiency.
Next is the pressure. The pressure may actually vary from one manufacturing plant to another, but is always maintained high.
Lastly, recycling. At each pass of the gases to the reactor, only about 15% of the nitrogen and hydrogen convert to ammonia. By continual recycling, the overall conversion is estimated to be 98%.
How does the Haber process occur?
Ammonia can be produced in the laboratory. It can also be from the thermal composition of ammonium chloride or from the reaction of the ammonium with hydroxide ions.
A nitrogen molecule plus 3 hydrogen molecules give you 2 ammonia molecules, which is the Haber process. According to the formula, there are 4 molecules on the left and only 2 molecules on the right.
If we want a room, for example, to get less crowded and therefore have less pressure, nitrogen and hydrogen will be grouped together to make a more compact ammonia molecules. Basically, the molecules are compressed before being delivered to the reactor where ammonia is produced.
Importance of Haber process.
According to Daniel Dulek, Haber process is the chemical reaction that feeds the world. These are some examples that show how important the Haber process is.
First, the Haber process in food production. Without this, farmers would not be able to produce enough food for 4 billion people. Take note that the world's current population is over 7 billion. Without the Haber process, up to 3 billion people will be living without food.
Second, the Haber process is important in terms of industrial purposes. Ammonia is a product of the Haber process and is needed for the production of fertilizers. The large scale of ammonia-based fertilizers, such as ammonium nitrate and ammonium sulfate, has made it possible to sustain global food production.
Third, the importance of Haber process in the field of agriculture. Soil contains soluble nitrates that are needed for plants to grow. When we harvest plants, the nitrogen is not returned to the soil. Therefore, in order to replenish the lost nitrogen in the soil, nitrate fertilizers from ammonia are used.
Benefits and harmful effects.
While we are at a time where the Haber process is being highly utilized, its impacts still have both positive and negative effects on modern society.
Ammonia has greatly contributed in food production, agriculture, and as well as the products we use in our daily lives. However, in contrast to these benefits are harmful effects on our health, our environment, and our economic purposes.
Humans who live in areas with greater usage of synthetic fertilizers are most likely to be at risk. The exuses of nitrogen in soil and water could cause health complications.
Ammonia itself is a health hazard as it is a toxic gas, irritating the eyes and lungs. The environmental factors are also considerably consequential. These consequences may come in the form of ground pollution or emissions into the atmosphere.
Ammonia is widely used as synthetic fertilizers. However, when the fertilizers in the soil has been washed out by rain and taken to the streams or rivers, it is highly dangerous for the living water organism as it acts as a water pollutant.
Nitrate interferes with oxygen circulation in the body, causing a lack of oxygen, leading to fatality. Also, nitrate in drinking water causes health problems, especially in infants.
Economically, ammonia produced from the Haber process has helped with the crop growth, yield, and production. On the downside, it requires a lot of money and energy. The Haber process uses tons of energy, consuming around 1 to 2% of the world's energy supply.
Its creation is extremely energy intensive due to the high temperature pressure needed to break nitrogen's molecular bonds.
Major imbalances in Earth's nitrogen cycle due to the mass fixation, high usage of fossil fuels as a source of power for machinery based on pressure and temperature, and also the destruction of forests and sources of water through the development of plantations.
While there are several negative impacts of the synthesis of ammonia, the scientific impacts and discoveries are prevalent, having revolutionized from modern world.
Mass production of ammonia is of great importance as it can be used for fertilizer, alkaline cleansers, and refrigerant gas.
It is also used in the manufacturing process of fertilizers, nitric acid to produce an alternative fertilizers, dyes, and explosives. Ammonia is also utilized in manufacturing of cyanide, allowing the production of synthetic polymers, and can also be used to extract ore from gold bodies.
The current process of nitrogen fixation is also not completely efficient, and a large amount is lost after it is applied to field due to runoff when it rains and natural gassing off as it seeds in the field.
To conclude, the Haber-Bosch process most certainly affects us. It has helped extensively with our crop production and allowed us to use less land and destroy fewer habitats. Nevertheless, ammonium-based explosives are in abundance due to the Haber process, and ammonia production has had many detrimental effects on our environment, leaving us to clean up the Haber-Bosch process problems today.
Uses of ammonia.
Now, let's proceed to listing some common examples and uses of ammonia. First, of course, we have fertilizers such as synthetic anhydrous, ammonium hydroxide for cleaning agents, and ammonia as refrigerating and air conditioning agents.
It is also used as a cleaner for water supplies, explosive pesticides, dyes, stabilizers for paper, rubber, beverages, and waste management.
Lastly, pharmaceuticals such as anti-malarials, sulfonamide, and also vitamins including nicotinamide and thiamine is also an example.
Safety guidelines in handling ammonia.
Now, handling ammonia also has its own safety guidelines in order to prevent hazards.
While dealing with products containing ammonia, the area should be well ventilated. You should also wear proper clothing and eye protection, since extreme exposure to this chemical can irritate skin, eyes, and lungs.
Mixing ammonia with chlorine bleach can be very toxic, as it produces chloramines, which is very toxic and can cause chest pains, shortness of breath, nausea, irritation to the nose, eyes, and throat, and even fluid into the lungs.
Accidental swallowing of this chemical can burn the mouth, throat, stomach, and can cause severe abdominal pain.
So, as we can see, the products of Haber process are greatly beneficial. Yet, on the other hand, it could greatly affect our health and environment in a negative way.
We, Synthetic Corporation, are here to warn you about the negative effects of the Haber process. We must lessen the use of these products and find alternatives for the sake of our health, our environment, and as well as the future generations.
Created by two German inventors. Do you wanna know who? They are Fritz, Haber, and Carl. Yeah. The S combine the nitrogen with the hydrogen. The cell reacts to ammonia. Let's do it again. A little bit of this, a little bit of that can turn into an element that has just sold it from the gas. Now did you know that this product is special to us? It makes up of the world's food production as well as the fertilizers and in agriculture. Be careful and use it in moderation. It's dangerous for sure.